let's try just to see why drds should be t. Well, let's think of drds. drds means, position vector r means you have the origin, which is somewhere out there, and the vector r is here. So drds means we move by a small amount delta s along the trajectory, by a certain distance delta s. And we look at how the position vector changes. Well, we'll have a small change. Let me call that vector delta r, corresponding to the size, corresponding to the length delta s. And now delta r should be essentially roughly equal to, well, its direction will be tangent to the trajectory. If I take a small enough interval, then the motion will be almost tangent to the trajectory, times the length of it will be delta s, the distance that I have traveled. Okay, maybe I should re-explain that on a separate board. Okay, so let's say that we have an amount of time delta t. So let's zoom into that curve. Okay, so we have r at time t. We have r at time t plus delta t. This vector here I will call delta r. The length of this vector is delta s. And the direction is essentially that of a tangent vector. Okay. So delta s over delta t, that's the amount, that's the distance traveled divided by the time. That's going to be close to the speed. And delta r is approximately t times delta s. So now if I divide both sides by delta t, I get this. And if I take the limit as delta t tends to 0, then I get the same formula with the derivatives and with an equality instead of an approximation. The approximation becomes better and better if I go to smaller intervals. Okay, are there any questions about this? Yes?
So the direction, it was the tangent to the curve, right? You said like when you draw your two vectors at tangent t and then t plus delta t, the resulting vector was tangent?
Yes, that's correct. So, okay, so let's be more careful actually. So you're asking about whether the delta r is actually strictly tangent to the curve, is that?
First time we're on the other side of that bottom curve, and your second time is somewhere else, it wouldn't be tangent to much of anything.
That's correct. Actually, delta r is not strictly tangent to anything. So maybe I should draw another picture. If I'm going from here to here, then delta r is going to be this arc inside the curve, while the tangent vector will be going in this direction. Okay? So they're not strictly parallel to each other, and that's why it's only approximately equal. Similarly, this distance, the length of delta r is not exactly the length along the curve. It's actually a bit shorter. But if you imagine a smaller and smaller portion of a curve, then this effect of the curve being a curve and not a straight line becomes more and more negligible. If you zoom into the curve sufficiently, then it looks more and more like a straight line, and then what I said becomes true in the limit. Okay? Any other questions? No? Okay.